Good. I'm Joe Ratzloff. It's a pleasure to be back in Omaha again. Tonight's topic is overcoming integration challenges with messaging. You could throw an asterisk on the end of there, of course. There is no overcoming, but maybe a way to deal with some of the unpleasantness that you run into from time to time. First of all, thanks to Justin and Julie for having me down here at Hewitt. It's my first time on premise here, my first chance to get introduced to the company. So a very impressive facility, and it's a pleasure to be here. And thanks to Matt and Brian as well for tolerating me one more time. So now, any of you guys see me last time? It was maybe a couple years ago out there at Farm Credit, right? Another great facility close by. So a little bit of an apology in advance because you'll see some redundant material, I'll confess to, up front. But tonight is a little bit different in that what I want to do is talk a little bit about certainly messaging, but with a flavor, bent towards integration. But biography-wise, as they say, I do live up in Sioux Falls. I've been playing around with .NET, I suppose, for 20 years. Did about a 3-year sentence on the Java side, I guess you'd say, for make Justin happy there. But it was really through that experience that I got exposed to messaging, though. So I will throw a bone to the Java guys in that they were about a decade ahead on that front. Worked with some early EAI platforms on messaging and really learned it on .NET when we switched back. So we had to find a way to do these sorts of things on the .NET stack. Most of my experience has been in banking and finance. So again, a bunch of different platforms and a lot of horror stories behind me. So tonight, right, some integration. So we're going to talk a little bit about some integration strategies, some of the patterns that you run into. A lot of that stuff, right, like files, things like that, right? Everybody does integration, right? You guys all writing web services, even still batching up some files, doing that kind of thing these days, right? We'll talk about some of the core messaging concepts. And even in messaging, there's always multi-step processes you have to do, right? It's pretty rare, I think anyway, that you'll take a web service call or you'll import some file to do one thing, right? It's usually a chain reaction of things, right? How do you want to manage that, right? It's the one SQL statement to end them all, or how do you want to decompose things a little bit, right? So that coordination of process is a key thing. And to kind of help with that discussion, I'll kick around a little bit of a scenario from my past. And we'll talk about why I kind of threw an asterisk at the top there, right? There's no free lunch. All these new platforms, different strategies have their trade-offs. And there are some, certainly with messaging and distributed computing. But I'm kind of a free flow speaker, ladies and gentlemen. So if you have a question, don't be afraid to interrupt me and just ask it, okay? And I will try to move relatively quickly through the intro stuff so we can get to a little bit more code perhaps at the end, okay? All right, so this is that sample, right? So where I grew up, we have a lot of things coming in, and just for a conversation piece, really, maybe we talk about a loan comes in the door. Like I got some business partner asking a bank to underwrite or sponsor a loan. So maybe they give those to us in a flat file, stick it up there through FTP, which has made the world go around for an awful long time. Or they make a web service, web API call, something like that, right? We need to really validate that loan, probably associate some of the information in that. Those tend to be kind of composite type messages, right, with a lot of information in it. How do we want to validate that? And then at the very end, if we decide we like that loan, let's pretend we have to give the guy his money, right? Or maybe most of it. Okay. Integration, right? So what do I mean by that? I think I remember hearing an old axiom, right, that 90% of coding is integration. I don't know if that's true or not, but if you consider the UI to be integrating the human, perhaps, then you're probably right. So, but it's about making things work together, right? And by things, we usually mean systems, right? Everybody has different partners, different interop to do with different, if you have SAP, as they have here, you have a legacy app, a mainframe, a business partner, right? Somebody's got to make all that stuff kind of work together. But really specifically too is if you're in kind of a greenfield or re-architecting scenario, a lot of times we talk about making service areas work together, right? And this SOA kind of hot button that's been popular here for a while now. So I always kind of talk about, out of this there's a book I read a long time ago called Messaging Patterns. It's this Gregor Hoppe, right? It's an old book, but a good one, and they kind of focus on a lot of these patterns. And in this talk, I kind of kick around 4, because I think everybody does the top 3 all the time, right? So exchanging files, shared database, remote procedure calls, right? Synchronous kind of invocations. And finally, our topic tonight will be more around messaging. So as we kind of circle the track here and we look at these, as we consider, maybe we look at some quality indicators, right? The coupling, what's the cost of coupling with a particular approach? And transaction support, right? As the little guy says, right? You gotta, nobody's happy if you skip a loan, or worse, remit one twice, right? So this kind of transactional consistency can be a problem on different solutions, and I'm sure that's a accurate caricature of almost everyone in the room, right? A happy developer, and we like to keep it that way. So how developer friendly is the specific approach we're kind of considering here? All right. So the first slide here is on coupling. Looks like I might be missing an image there, but imagine a clock being there, right? So this type of coupling is, how interdependent are things, right? If X depends on Y, if system X depends on Y, then they're coupled. And there's 3 real kinds of coupling that we look at. The first is this platform coupling. And it's kind of germane, as we talked about Java, right? Interoperability. When I started coding on Java, we were using Corba still, okay? And RMI. Those were kind of easy to do on the Java stack, but if you were a .NET guy, web services hadn't quite come into form yet. And so doing interop was a little tougher, right? So nowadays, that's a little better story, right? We have Web API, we have JSON, we have interops, not too bad, and of course, different data exchange protocols exist. And so, it's important that we try to keep the interoperability story as good as we can have it be. Temporal, right? Coupling having to do with time. If I do something, but then I'm waiting for you before I get execution back, then we're coupled in terms of time, right? So synchronous invocations, the call stack, if I make an RPC call of some sort or another, set that debugger, right? You're waiting until that call comes back. You call SQL, usually, right? You're blocking on that line of code. So in that model, right, that's what this, the sequence diagram is really showing is time-based coupling or temporal coupling. So, we want to minimize that if we can for scalability purposes. In a modern system, the other way I kind of kick around that, with RPC, right, you're going to hold a thread of execution for every invocation, right? And we'll probably talk about that a little bit more when we look at RPC calls as a pattern. The last type of coupling is this spatial coupling. And I always kind of use a network load balancer as an example, right? How well does a system manage the location and availability of things it depends upon, right? So think of it like SQL. We have this connection string, but if you have a high availability on your SQL server or a website, if you decide to use a load balancer, your code's not really aware that there could be any node in a farm can kind of take that invocation. But when you're dealing with things like messaging, you want to make sure that your system can react favorably, right? So this notion of like a dispatch agent, right? Something that's intermediating the call is helpful, right? It would stink to have to go recode every time a database went down, or if your load balance to go have to change the config every time, right? So it's good to have some adaptability in terms of your spatial coupling in your system as well. So it's pretty impressive animation, I'll have to admit. But if one machine goes down, right, you kind of want that thing to be able to sort it out on its own without a lot of intervention, right? So these last two quality indicators, right, we spoke of already, this ability to have transactional support. It's rather nice in SQL Server that a transaction will roll back. But if you're dealing with other things, right, like a file system or other things, even some messaging platforms, right, you don't get that same protection. So that is something you have to account for in your design. Otherwise you can get these duplicates, inconsistent systems where you are, who's ever had to go run a query looking for double orders that might have come in overnight, or did I charge that credit card twice, right? These kind of things happen. Most people deal with those. And then the skill set learning curve. Is it something I have to, do I have to bring in a ton of people to teach my staff a real proprietary and trick kind of platform? Or is it something people can kind of pick up? Does it have some intuition to it, and does it just kind of make sense, right? We've all used platforms, be it for telephony or integration, or, who hasn't used a really great tool that promises you'll never have to write another SQL query by hand again, right? Be careful what you wish for, right? So I was talking to Matt earlier. I'm pretty old, right? So I remember a tool called Visual InterDev, right? If you want to talk about tools that tried to make things a little easier than perhaps they should have, right? All right. Any questions as I kind of keep on trucking? All right. Okay, so kind of recursing back through these 4 integration patterns, right? We're talking about exchanging files, right? Does everybody still do that, right? I mean, I work in a bank. We still get files in every day, all day long, right? Thousands of them. So if we look at like the pros and cons along those lines, right, it's pretty nice, right? The pro is the platform coupling. That's not too bad, right? We have, it's very easy to interop. Every language I've ever been around, it's pretty easy to parse a file. Things like XML made that even easier, right? Schema bindings to different documents also have made that easier. So the multi-platform stuff is easy. Skill set, not hard, right? Everybody, a lot of times as a new developer, you get to be the guy that deals with the file parsing and the batch jobs. Spatial coupling, maybe not as strong there. I do say it can be, it can be a little better, but sometimes you can load balance an FTP server, not mid-file, but you can make things available that way. On the con side, right, it is temporal coupling, right? You do not, once that file is in transmission, you do not start reading it generally until that guy's done, right? And the transaction support, not so great either, right? You're hoping you're not halfway through parsing that file and then you find that weird Julian date somebody decided to stick in there, or that one zip code from Canada that blows the whole thing up, right? So there's some challenges to that. Shared database. So this is kind of like, maybe like a staging table, but almost like a live table. So imagine that I have a scenario where Platform A just starts writing data to a database, and then Platform B just out there selecting those rows out, maybe updating them too, right? Mark them as taken. Anybody do that kind of thing, right? I think a lot of people do that. It's a good way too. That's how we used to bridge things like Java to .NET. Everybody's got a driver for a database. It's just trade. So again, pretty easy. Most people, they give you umpteen ways to connect up to a database these days on every language under the sun, right? Pretty straightforward platform coupling, again, cross-platform. And you even get transaction support, right, on most databases. If I'm writing to that thing and I'm involved in a transaction, if that thing rolls back, I should be protected as much as I can be. So, and the skill set, pretty easy, right? So what's the bad things, right? Coupling, right? What happens if I'm really wailing on a database and you're trying to read from it? Eventually you're going to get that you've been chosen as a deadlock victim, right? Or something like that. So anybody know a great solution to that? How do I make that go away? We had one magic word we used all the time. No lock, right? Who cares, right? I'll just no lock and I'll get those things. But this leads, right, to the obvious one. That really screws up your transactionality, right? It's very easy to have a row be written. I do a dirty read on that guy, and then he rolls back, and now I've got that phantom. The guy that applied for that loan might be pretty happy because he could get triple the payout if you're lucky, right? Other things, right, is it's kind of a good schema, right? So database yield structure, you got a good contract between systems, but it can tend to kind of bleed out a little bit too, right? Where you get these, everybody kind of reading and drinking from this same big database. It can kind of lead to that big ball of mud architecture too a little bit. Rpc calls, right? This is easier than ever these days, right? So we have a million different API technologies. You look out and you look across the internet. There's a lot of people making it pretty easy to use RPC calls, web API, all sorts of things, right? Started with SOAP, WCF. So, it's pretty good spatial coupling too, right? Because you can load balance a lot of those kind of services, make them high availability. Some of the cons are, again, transaction support, right? What was it? WS Atomic, right? Anybody ever see that? Really? How many of you guys have seen Sasquatch? There's one, yeah. So no, it's kind of. I've seen it too. But it's pretty rare, right? And it doesn't always work, right? So this notion, they had patterns around it, but most people don't go for it, right? I mean, and it's not for every type of transaction. If you're just querying things or looking up the weather, who cares, right? But it's that key thing when you're doing something, right? That's when you want that transactional protection. But it's also this temporal coupling, right? These are blocking RPC calls, right? So the best example I can give of this actually goes back to when I first started in banking. I had to supervise the team that did the IVR, right? That annoying telephone operator system, right? The automated attendant, right? So you'd call the bank and it'd say, please enter your 16-digit account number, right? And, for the whole time you're on that call, there's a port on that phone, pre-VoIP, right? There's a port on that phone switch tied up all the time, right? Usually calling back into some system, gathering up data, screen scraping, maybe an old 3270 emulator, God forbid, right? And pulling all that stuff together. And but you could see, right? So as you watched how the scalability of that worked, when it would be the noon hour on a payday or something like that, you just had to stack these systems up because they would get saturated. And so I used to joke all the time. I said, the most scalable IVR we could make would be one that had a much simpler script. It would say, please enter your 16-digit account number. Then what? Just say thanks and hang up. Right? Because you had caller ID, and then at some point in the future, just call them back and say, your current balance is $50, right? It would scale a lot better. Why? You took that time element out of it, right? Just like text messaging, right? People love text messaging, and I think it's kind of that neat thing because you don't necessarily expect an immediate response, right? So it lends scalability to it. And you see that when they have these hurricanes, right? God, please text, don't call, because their telecom systems can still handle that text messaging a lot better because they have that eventual delivery kind of model, right? Does that make sense? All right. So messaging, right? What's so great about it? Well, it does offer lower coupling, right? It has the messaging becomes a contract in and of itself. It's like me writing a note on a piece of paper and passing it around. Right, it's left in my hands. I need not care about it. I can hang up the phone and no problem, right? So it has good abstraction from routing and location, right? The patterns in messaging allow you to address it to where it needs to go, and usually some underlying infrastructure, right? A transport like MSMQ or JMS. These things will address it to a recipient or a subscriber or somebody that you want to receive that message, okay? So, you're abstracted from a lot of different things. And if you're using transports like MSMQ on Windows, it does support transactions. So that means if you pull a message out of a messaging queue and you interact with something like a SQL Server database, If something goes haywire, it's going to go put that message back, and then you'll handle it on the next cycle, right? But not all transports are transactional like that, right? So that can still be a problem. But that fire and forget, this ability to store messages and forward them eventually. Has anybody used MSMQ or done any messaging on that, right? So MSMQ is kind of unique in that way. When I send a message, I address it to somebody else, and it is MSMQ that stores it first locally. And then it'll go through the outbound queue of MSMQ, trying to, it'll just beat on the door forever, if it has to, trying to get you over to that other machine and into the queue that you had suggested, right? Can you guys hear me okay? I notice I keep wandering away from the old microphone here, but okay, so let's keep going here real quick, all right? Any questions, though? Nothing? Okay. So if you're kind of committed to messaging, there's a couple different prevalent patterns out here, right? The broker and the bus. So like the broker, if you read like the definition, it says, how can I decouple the destination of a message from the sender but still maintain central control, right? I still want one master and commander in the center, right? So that is called the broker. And you can see from the illustration, it's more of a hub and spoke kind of scenario, right? So that's a pretty common pattern. BizTalk's a little bit that way. If anybody runs BizTalk, it's got one big message box. Tends to be, this is my BizTalk server. This is my Azure service bus up in the cloud, right? I got my messages. There's one postage box, and everybody that wants to deal with it kind of connects around in a circle, and we interchange information through that one hub, right? The other prevalent pattern kind of talks about this notion of how do I add systems dynamically, right? What is an architecture that enables separate applications to work together, but in a decoupled fashion such that applications can be readily added without having to affect the other applications. So that is more like the bus model. It's kind of like Ethernet, right? I go add a new device to the network, I don't got to go tell everybody else about it, right? I don't go into each device on the network and tell it, hey, there's a new printer. That gets its IP address, DHCP assigns it, and it just extends out, right? So it's much more like that, okay? So, again, now in either one of those patterns, you get into these message exchange patterns. There's two key ones I'm going to focus on tonight. One's called request response, okay? And this is, you can kind of see by this illustration, it's a lot like if I took a chunk of paper and I wrote a message on there and I dispatch it to one of you gentlemen, you write a reply on it, you send it back to me, right? That's just what's happening here, right? The requester and the replier both communicate through a different channel. Another term for that would be called full duplex, right? But it's a lot like an RPC call wrapped with a message, right? So you usually got a command. I'm asking for something. Here's that new loan. New order accepted. And I'm waiting for a reply, right? Always waiting for a reply. As opposed to publish and subscribe. This is a little bit more like broadcasting things, right? Very similar, but it's really more about the nature of what events are in a system, right? So when we talk about messaging, the axiom I like to use is an event. You're not asking for something to be done. You're informing others that it already happened, right? So like the old click events even in forums and stuff like that, right? It's not asking you if it can be clicked. That's already done, right? So I'm just telling anybody that's interested. So like delegates even, right? You send a delegate into an event handler in an application, and that's what it does, right? He just informs you of what's already happened. So in like the model here, what you'd see is subscribers will contact the publisher and register a desire to receive messages of a particular type when they happen. The publisher will remember these subscribers, and every time it comes across one of these guys, it'll look on the list and say, who am I supposed to send that to? So it's a lot like request response, but there is never a reply, right? The publisher really does not care if you do anything. So it's kind of a prevalent thing in that bus style, right? If you remember that definition of the bus, I'm adding things to the system without affecting the others? Well, if they're publishing events, the very nature of that is they do not care. I'm going to tell you about this order that came in. I guess if you're interested, subscribe, but whatever. I don't care. I'm just telling you. I'm not aware of the 50 things that happen. I just announce it to the rest of the world. Does that kind of make sense? The difference between command messages and events? Okay. So if you're going to do messaging, you get into this mode where you got a lot of stuff to do. You got to create messages, handle them, worry about reliability. What am I going to put in the message queue? What am I going to serialize? How am I going to deserialize it? How should I secure it? What if I got to encrypt it? Right? How do I scale it out? How do I monitor it? What if these messages get lost? Or what if they, they're never going to get lost. Let me rephrase. What if they end up somewhere I don't expect? Right? How do I detect that has happened? Right? So there's a lot of stuff, right? How do I store these subscriptions? What if I get a poison message where I pull it out of the queue and it's got something I just didn't expect? Right? What now? How do I fix that guy? Right? So the moral of the story there is find a technology, right? It doesn't need to be end service bus, but it's tough. If you've coded on the metal in MSMQ, as a few of you guys have, you know what that's like. You got to pick what you want to put out there, and there are some things that it gives you, certainly, out of the box, but a lot of things you do have to kind of sort out for yourself. All right, so really, what is end service bus? It's a bunch of DLLs, people, right? It's just a library. Now, the platform has some additional tools, but it uses some terminology, right? A hook into the bus, let's say, is called an endpoint, right? An endpoint is often a Windows service. Okay, we provide a Windows service that can host your handlers that handle messages. And that's kind of where the name comes from, I would imagine. It predates me, but it's n number of Windows services kind of conspiring to form this bus. All right? So they can receive messages, subscribe to one another, do these sorts of things. You can host an endpoint in your own process as well. So if you're a web coder or even in a console app, as you'll see in my demos, it does not matter. I new the thing up, initialize it, I can register handlers, and I get a hook to the bus. So another key piece of terminology is this notion of a queue, right? Every endpoint has a queue, right? And that depends on what transport you choose. So the transport is the underlying means by which messages are exchanged. Originally, it was only MSMQ. So it would be a nice library on top of MSMQ, but in the years since, we've expanded that to include SQL Server, so it'll kind of use tables, more in that hub and spoke fashion to exchange messages between endpoints. And it can also use Rabbit MQ, and it can use Azure, both Azure Queues and Azure Service Bus, right? So it doesn't matter. And you're kind of abstracted away from that, in that the code kind of works the same way, mostly, with some configuration changes regardless of which choice you make. Okay? Any questions? All right. Well, let's see what happens here. This is going to be interesting. So I gotta wrestle some technology, folks. So let's see what happens here. I'm going to try to bring up Visual Studio and my virtual machine. So okay. Okay, so I have an example here, and let me squeeze this down here a little bit. Okay, can you guys read that? I tried to zoom it up here a little bit, make sure. What do I got going on here? Well, I'm going to have to kind of wing it because I can see I goofed up my virtual machine's resolution, but let's try it. So what I have here is just a Visual Studio solution where we're going to do a little bit of request-response messaging. So you can see it is just Visual Studio. I have a client and I have a server, and I want to send messages in between them. Okay? So if we look at the client, I really just went out to NuGet and I referenced the end service bus core. There's some plugins we'll talk about perhaps a little bit later here. And then I need to have a message to send between each other. So in end service bus, messages are just POCOs, right? Just plain old CLR objects. You have the option of either implementing an interface or just declaring what messages have what type of functionality. So let's look at one. All right, so you can see this is just a POCO. Now in this case, I did choose to implement the iMessage interface, which adds some additional information to the message body. But so this is the message I'm going to send to that server, and then he is going to reply with this response data message here. Let me see if I can get this guy. Data response message, data request, right? So there's not much difference between them, but you can kind of get the idea. I have a client, I have a message, and I want to play kind of pitch and catch with this server, right? So if we come out here and we look at this guy, and let's take a peek at the client's code. So initially, you know, this is just a plain old console app here. All right. So you'll see my references at the top here. Got my messages, my end service bus, and then I have to configure the bus, right? So I've got those libraries. I create a configuration for it, and I make some decisions of what I want to call my endpoint. How would I like to serialize the messages? Do I want to use binary, XML, JSON? And some of these persistence things, in the case of retries and stuff, I have to decide how I want to store information. And that can be in memory for demos like this, or into a database, of course, for a more realistic scenario. But the key thing to look at is really, what do I need, right? I need this. I need this bus object, because he's got the one thing I want to do. I want to say send, okay? So we instantiate this bus using the configuration we created, and then really the glorious part of it all is I create this POCO, right? I var up that, I new up that message, and then in this case I'm saying bus.send, and I'm saying send it to the server of send this message, right? Any questions on that little snippet of code? But not too hard, right? I mean, that's pretty easy. So if we come over and we look then at this little server console app, it's very, very similar, right? So once again, I have a program where I come up and I build a configuration and I name my endpoint. And notice I had to pick a name that's consistent with that other guy, right? It's bus.send, I got to tell it where to go. So this is the name of the endpoint. And in the case of this local demo, I'm using MSMQ. So in fact, that will be the name of a queue that's created automatically on this system, okay? So down here, I just create the bus and I start it. And then I just do a read line to just keep the console app running, okay? Because I need this handler to be bootstrapped the entire time. Just go in here a little bit. Right? So if you look at this guy, this would be typical of how a handler works in end-service bus. So you can see this, again, there's not a lot in this code, but you see at the very top, right, I have this I handle messages of type request data message. So that's telling the bus that if a message arrives of that type into my inbound queue, I want you to fire the handler within this class, right? And so you see this request data message in the handle method, and at that point, it is a lot like a click handler, right? I'm just get delivered that message, and I can do with it whatever I want, okay? Now, you also see this iBus interface up here, right? So that is how I can use the bus. The framework uses dependency injection, and it sees that interface, right? So it wires this thing up using IOC. So it's looking for those marker interfaces. It says, oh, I see I have a handler. Right, so I could write a whole bunch of these handler classes if I felt like it, and they will be wired up. And if I put the bus interface there, it'll inject a handle to the bus. And what would I need it for? Well, to reply, right? So you can see in this little code here, I'm receiving a message that the sender sent me. I'm building that reply message, right, that response message. And at the bottom, I just say bus.reply, and I say response. And that sends it back to him. Make sense? So, if you were extra observant, if you go look back here at the beginning, we look at this data response handler. So the sender himself also has a handler, right? Because he has to be able to process that reply from the server, right? So he did the same thing. He just says, I handle data response message, and if we push play, you get to behold the sight of two wonderful console apps here. But this is the sender here on top. And so in this little test harness, if I just push enter a few times, it takes a little while for MSMQ to spool up. But you see how it sent those messages, and then they all came streaming back. Now if I do it one by one, see how the response is coming back immediately, because he's caught up. But this is that temporal kind of async messaging thing I was talking about earlier, right? I'm not guaranteed when they'll come back. I'm just guaranteed they will, right? If I chose wisely on my transport. That's a lot of stuff I just spewed out there in about a few minutes flat. Does that make sense? Everybody, I'm looking around. Question? Up front?
So on the server, if you have multiple handlers for the same type, is there any way to guarantee the order they'll be handled?
There is. That's a little bit more complicated scenario, but you can register different handlers, and there's a little markup you can put in there that says I specify. You can make a interface that says I specify order of handlers. And you can say first this one, then that one, then the other. So the question was about how do I get multiple handlers of the same type to fire at the same time, or in a controlled fashion, rather. There was another question back there. Go ahead.
You mentioned interfacing with RabbitMQ.
Yeah.
So when you're using that, then are you functioning as an AMQP broker?
We don't use the AMQP APIs. We're actually using the raw Rabbit ones. Okay. So, in fact, if I did the same demo, and I could chance it here, but I'd be tempting the demo gods here, probably a little too much. But the code, in fact, is no different. So when I started these console apps, you saw maybe in the config it said use the installers. What that meant is if there's infrastructure missing, the framework will try to install MSMQ if you need it, for example. If we had a Rabbit installed, which I do on this VM, it'll make the queues in Rabbit if I chose that as my transport, and the demo works exactly the same. You would be unaware that it was really Rabbit under the covers versus MSMQ. And the same is true if I had SQL, right? But instead of making a queue in MSMQ, it would make a table in a database of my choosing, okay? And so I would write the row to your database, right? So the sender would send the row in by writing it to the receiver's table addressed for him. And so instead of peeking a queue, they're all kind of peeking their own table. And you can think of it even a little further if you think of Azure, right? If I had a connection string that pointed and be out to the cloud, it would be doing the same thing. It would make a queue for each endpoint, makes its own queue, they address it. So that's kind of the advantage of the API over some of these, the raw transports themselves, is you get that layer of abstraction and you get the ability to do some things that maybe those platforms don't automatically do, like pub sub and things like that. Up front? You have to pull down a different assembly from our beloved NuGet, right? And then the connection string has to be specified. So there are some specific configuration changes you have to go with there. And there are some other things that change a little bit, but trying to be respectful of time here. We got a little bit of a late jump. It might run a little over. Are you guys okay with that? Or do we got a hard stop at 7? Does anybody else drone on like I've been doing? Or can I run over, or should I shut it off shortly after? Okay. Well, let's keep going, okay? So we kind of touched on request response here. Let's just quick do sub real quick. And you'll see some things that do not surprise you already on this one demo here, okay? So these demos I'm doing actually are out on our GitHub repo. And on the website, actually, now you can just go download them. But it's really easy to bootstrap these and kind of learn kind of what's going on under the covers. All right. So you can see pub sub rabbit is in here, and I'm not going to do it. I've already got a screen resolution issue. I don't need to exacerbate things here, right? Okay, so let's look at this little guy here. So very similar kind of thing, right? So I have a message class, right? That's really complicated. It's got a few different events in it. And again, you'll see that they're exactly the same as what we were doing before. But you see this here? Where I say my event, right? I'm choosing to use that interface because I'm informing the framework of an opinion. I want that class to only be able to be used as an event. If you tried to do a bus.send with that, it will give you an error. You cannot send an event. You can only send a command, right? And so we have some events defined. And so when we come and we look at the publisher, we're going to see some different things than what we saw before. Okay? So we configure him as was the case before, but we really better have a persistence option. What does the publisher have to remember as we kind of talked through it in the beginning? Yeah, who are those subscribers, right? He has to be able to remember that. So in this case, I'm telling it in-memory persistence, but we do provide a copy of RavenDB with NService Bus that can be used for storing this kind of thing. And you can use nhibernate to store it in SQL as well. Okay? But that's a key thing. But otherwise, what do we see, right? It just starts the bus, and he's not really doing anything. Right? So he's just sitting there. But it comes down then, and we do loop into the start method here, right? And we say, okay, I want to publish. But we don't see any addressing of everything, right? So you see these case statements are really the demo switching between different types of events to demonstrate that subscriptions are type-based, okay? So when you subscribe, you can say, I want to subscribe, hey, endpoint, I want to subscribe to everything implementing this interface or of this type, okay? And so it kind of churns out a few different options to demonstrate that capability. But at the end of the day, really each of these are very similar. At the end of the day, we just say bus.publish. Right? And nowhere in this one do you find where it's publishing them to. So in fact, if I start this guy up first, gosh darn it. Darn you, screen resolution. All right, let's see if we can draw it over here. All right. I tend to I've just learned that it's a bit of a well, I'll just say a bit of a gamble, right? So it's running now, right? I got to be happy. So this is a good suggestion, though, to get it off the dock. So let's start up this publisher. Right? And he doesn't do anything, right? So if I hit enter, who's he publishing to? Nobody, right? So let's start up one of the subscribers and then see what happens. Yeah, same problem. There it is. You're going to still let me undock that guy, right? We'll just do it again over here. Still too low. You know, at home I use an amber monochrome monitor, so I don't have these kind of issues. All right, so let's see. So let's go find our other guy here, right? So this is our publisher, and I just wanted to toggle over here real quick because we're going to see a couple items in the log. Okay, and if we read those aloud, it just says subscribing sample pub sub subscriber 1 to message type my message dot other blah blah blah. So those are the subscriptions rolling in, right? So now that I started, he's got 2 handlers in him, and he's telling that publisher, I'm interested in these 2 types of messages, okay? And so now, as you might imagine, if I start hitting enter, but you noticed he didn't go, you know, that subscriber didn't go crazy, right? Because there was nothing pending for him. He hadn't subscribed yet, right? So in that request response example, when I fired up that other guy, you know, all those messages were waiting for him, right? There was no subscription, so that publisher just wasn't aware of anybody, so he was broadcasting to 0 subscribers, right? Does that make sense? No, not in this case, right? So you can make the subscriptions more durable, right? So if in fact we had stored those subscriptions in SQL Server, it will survive a restart, right? So when I start that publisher back up, his memory is already there, right? So in fact, when we go look at the code here for the subscriber, you'll also see that he really didn't. Oh, no, not you. Solution Explorer. Okay. So if we look at the subscriber and we look at his event message handler, we just see the handler. How did he actually subscribe? Or how does it know, right? So in fact, what happens is there's this notion called auto-subscribe. Look at his config. You will see these message endpoint mappings in the config. Okay? And this works when what we're doing here is we're saying, hey, if you're interested in this type of message called my message, you should send your subscription to the following address, because that's where they come from. Okay? And so when I started it, we didn't have to go explicitly subscribe. It just saw when it reflected upon those assemblies and said, oh, I see a handler. I see a couple of them for type message. I'm going to just go ahead and fire off these subscriptions on your behalf, right? So it's a configurable thing, but you can just do it that way, right? And then you get your subscriptions in there, and that's how it auto wires up those subscriptions. Okay. All right. Any other questions on PubSub in the back?
When you're creating messages, can you specify a time to live for the messages if they're only valid for a given time, so you don't just sit in the queues forever?
Yeah, actually,
It doesn't matter if they get beyond a certain age.
that is absolutely you can, right? So that is very valuable in a high volume event, especially, right? Because events, you know, we talked about how they're things that already happened, but if it's a stock ticker price or something like that, or you know, it has a useful lifespan, right? After an hour, you probably don't care. You know what I mean? And so you would do that. So you can put an attribute on the message itself and say its time to live is, you know, 20 seconds or whatever. And then if the transport underneath supports it, then it will be honored. So like in MSMQ, if you go find those messages, you'd see a little timer, right? If you go look in there, you'll see it counting down until the point where MSMQ itself will delete them. Okay, but I know like SQL Server doesn't support that, right? Because it's not really a messaging infrastructure. So that would be an example of a feature that is really kind of dependent on the underlying infrastructure. But that's a great question. Any others here? Swing back over to the demos here. Man, now I got to figure out how to get out of this stupid VM. What is my hotkey on this guy? Okay. All right. So back into this. not seeing what I see. So let's pretend that we are. All right. Okay, so we did the pub sub thing, right? So in our sample scenario, we talked about, loans coming in, getting validated and remitted, right? So let's talk about a couple ways we could do that, kind of in the spirit of integration, right? So we spent a little bit of time, so I'm going to move kind of quickly here. We're a little bit after 7, so let's imagine, right? So I've got these files showing up with this loan info, right? So we got to decide how we want to combine our little patterns we talked about to get this job done, right? So really what I want to do is in this loan request, there's information about a customer, right? Like a customer ID. I should probably make sure that that's actually a real customer before I book that loan, right? Or a real reselling loan partner, right? The other thing I need to do then is validate the loan itself. Is it within the amount I want to loan? Have I reached my lending limit for that program maybe, right? Just typical kind of boring financial services logic that, God willing, none of you are ever exposed to, right? But so we'd have to validate that loan. And then if we're happy, we go to this remittance management system, right? And we send them their money. So one way, right, I've seen this done every bank I've been at, from large to small, is, all right, what's one of the bigger tools in your toolbox? Let's get a database, right? So let's take those loans and let's set up some batch jobs. Okay, so we're going to bring this file in on FTP and do a little ETL job, and we're going to stick it in a table. Probably in the same format it came in, right? Or whatever, right? You guys probably see a lot of stuff too. But one way would be this. This is clearly then going down that avenue of shared database, right, as we kind of went through the integration options. Right, so now I get a job. So I get a job scheduler, and I write a job that says, hey, for customer validation, I'm going to just go get me all the new customers that are on a loan, and I'm going to do some kind of query against the customer management system, or call an API. Say, okay, yeah, he's a valid customer, so I'm going to go update that row in the table and say, this loan looks pretty good, customer validated, right? So I always used to kind of say, I take all the A's and I turn them to B's. Right, you were new, and now, so you're moving down this state chart, right? It's pretty primitive, though, but effective, right? I saw many, many big systems run this exact way. And so now you got this other job running, maybe every 10 minutes, maybe every 5, if you got a really good SLA, maybe once a day. But that was how you kind of tune it. And he says what? Go find me all the B's, go call into this validation system, and update the loan, and turn those B's into C's. Right, or whatever, right? And so you get these kind of competing polling jobs on this shared database, right? And then finally, go find all those valid loans and remit, right? So what's bad about that, right? We talked about all that stuff, right? So the hard part is, right, some dude probably wrote a report that shows you what the status of every loan is all day long, right? You can watch that. Managers will go hit F5 on that guy all day long, right? And probably with no lock, right? But these are the ones where you get into that creepy kind of no lock situation, right? You could imagine somebody drops that giant file on you, and ETL works pretty good in SQL, right? I'm not going to badmouth that. That's certainly a valid and very, very fast technique, right? And you're doing some good things, right? We're getting it into some safe ground here, right? You can trust a database. You might get a lot of locking and blocking, but you know what? You're not going to leak data. You might get some errors, but you're going to be consistent, right? And that's why a lot of people do it that way, right? You guys have done this, right? I certainly have. This is how I pretty well grew up, right? Okay, so another integration story. In this case, we're going to do it slightly different. We're going to bring it in and stick them in the same old table, but then we're just going to have a process that does one big query. Okay, so go get me a guy, go get me a loan, go give me that top one where approved is no, or something like that. And then what I can do is I'll just broker it right from that process, right? So this job runs, and he's out there looking at the database, grabbing items, and then he's going to go call each system in turn, right? Kind of go around the horn, right? So he's kind of that, kind of brokered processor, right? And so we used to do those kind of, maybe that's a Windows service, right? Maybe that's a stored proc that gets kicked off every hour or every 5 minutes, right? But instead of little competing consumer-y kind of jobs, it's one big guy, right? So one of the advantages of people do that with is because it's easier to take that one process then and invoke it, from a web service. Right now I got everything being done in one spot. It's pretty easy. I can take that one class that knows how to call all 3 web services, right? How many people have wrote that, right? The one web service call comes in, and then I turn around and I say, do this, do that, do this. And God, please don't have an error in between. Right? Because you're gonna have a little bit of a problem there, right? Does that make sense? Right? You got to see those patterns, right? So let's talk about, just some ideas about how you could do it a little bit differently, right? So what if I said, I'm going to take an endpoint, right? Because we saw how I self-hosted the bus in a console app. That wouldn't be super hard to start reading a file in there, right? And so every time I come across a row, build a POCO as a message, and I take that guy and I mix my messaging patterns up a little bit, and I say send a command into the bus. And just this little guy here, this endpoint here, is a bit of a crutch because he's my integration gateway. Because I probably get in some big massive message, right? It's not just a loan, it's a loan with a customer with a bit of information attached. So I parse that file and I send a command to this guy, and then he turns around and he tells the rest of the world about it, just as we talked about, right? So now I'm going to go pub sub. Hey, I got this loan. Anybody interested? I hope so. I did all this work to publish it, right? So God, please somebody listen, right? So he tells everybody, all at the same time. Customer management, here's the deal. I got this loan. What do you think? Do you like the customer? Because that's all he cares about. He could give one darn about the loan itself. All he's there to do is validate customers, right? So he would come out then and he'd say, hey, I approve the customer. Well, maybe I subscribe that validation system to that event. And he says, well, I know about this loan, and I see that you validated the customer. So now I'm going to go ahead and call my little API and see if I like the loan or not. And what do you suppose he might do if he likes the loan? Right? What should he do? Throw an event out. Tell somebody. You don't know who. You might be telling five different guys, right? Customer approved. That's a bad slide. Sorry. What should it say? Loan approved, right? So don't code it that way, right? But note to self, fix the slide. All right. Right, so then what happens, right? So remember, right? So these guys are waiting, right? These 2 guys are sitting there. They're at these two service areas. These endpoints are waiting, right? So it's almost like a latching relay if you're an old electrician or something like that, right? So I got the one guy, but I'm not going to do anything until I see this other one, and now I'm going to do my bit of work without regard for who's downstream from me, right? This goes to that bus strategy I enumerated earlier, right? How do I add functionality without monkeying with everybody else in the system, right? So these events come out, and then the loan is remitted. So we kind of call that an event cascade almost, right?
So what happens if one of those services happens to be down at the moment with that event?
Yeah. What would happen, as we saw in the demo? They'll just queue up. And when he comes back up, they'll go berserk, right? I mean, if you got enough threads on them, right? So you get that store and forward kind of capability, right? So that's that.
If they hadn't subscribed to it yet.
Well, if they hadn't subscribed yet, but this is where you need to have you have to have it together. Let's say, right? So you got to, so in a case like that, right? You would make those subscriptions permanent, right? We would put those in a database, and we would just never delete them. So when that endpoint comes up, right, he always knows. But that is a weakness, right? You got to make sure everything gets wired up. Is there a question in the back? I'm sorry, sir. No. So that's a warning sign. Maybe he's yawning. I better get moving, right? Okay. But ask yourself, right, in that last slide, how did this endpoint wait, right? So like this validation guy here, he heard about the loan, but then he didn't do anything, right? He waited. He said, well, I got this event. How do I coordinate 2 events that happen separately? right? There's time in between them. I needed to receive one, remember that I received it for this loan. But then only when I received another event that correlated to that very same loan should I go ahead and call into the loan validator, right? So this gets to that orchestration thing I talked about earlier, right? That's called a Saga in N-Service Bus, right? So it's like a handler with a memory, right? So long-running processes, they have a state management capability. So we saw those handlers, how simple they were. Imagine if I had handlers kind of like in a web page where I have session state, right? So if I get an event or a message comes in, I can take bits and chunks of it and store it, and I can declare a key, a session key, if you will, right? That'll allow me to recorrelate information from various arriving events. And when I feel I'm done, I can just terminate my session, right? So that's really what a Saga does. Does that make sense? So both of those guys are really Sagas. They're started by the loan received event. It instantiates them, they get their statefulness, and then they're just laying in the weeds waiting, right? They write a record to a persistence store, and they go to sleep. And when that next message comes in, it wakes up and says, wait a minute, I got another event. Who do you correlate to? And it fishes out of the database the data that it left behind. It says, oh, okay, I see that now is the time. I've already know about the loan. I already got that customer validation, so now I'm going to go ahead and remit. Does that make sense, how we're kind of correlating these things and that importance of being able to wait? Right? So again, their triggers are messages. Specific messages are designated to start a Saga. So literally there is an I am started by, and you can say which kind of messages start you, and you declare the natural key that you want to use to identify individual Sagas. So like in this case, we might pick like a loan ID, right? All messages pertaining to the same load correlate to each other, right? You can define a Saga data class that you can write to, and that'll be stored on your behalf in between invocations, okay, for the life of the Saga. And so, should we do a demo of that? Any questions on Sagas? And then that'll be pretty much it. Any questions as we go into that? Okay. Well, look what happened while we were gone. Let's see here. Now I'm going to try to duplicate the display here. Is it extending again? Okay. Well, maybe I'm going to do something different this time. Well, it's probably going to cause the same trouble. So let me... Yeah, I'm going to have to change my rig here a little bit. I apologize. You guys are pretty patient. All right, so let's go back to, what we're going to do is just going to change it to duplicate again. All right, and we're back to the ever so small resolution. Okay. Here we go. So if we look at this loan remittance guy, right? I don't know why I put customer management in there, but we can see each of these projects is a endpoint, okay? So let's pick one that really represents the what a Saga is all about, like loan remittance. So again, right, the thing I want you to kind of pick up is if you did any of the other methods we saw, right, you'd have all this code written, right? You know what it takes to validate a loan and call that web service. What we're choosing to do is we're plucking that out of these other systems and putting it in these handlers, right? So when you get into messaging, rather than having, big, long procedural chunks that are calling 3 web services in a row, you take that same code and you chunk it out of there and you stick it in a handler, right? So you end up with a little bit of code in a lot of places, okay, as opposed to all your code in one big spot, if that makes sense. So if we come in and we look at this loan validation guy down here at the bottom, or loan remittance rather, what we're going to see is, again, very same bootstrapping, right? Once again, I have to choose persistence, okay? And in this case, you can see I decided to use nhibernate. I don't know why. I'm surprised that that's actually working. I didn't know I had SQL on here. So I'm getting lucky. All right, so we come down here and we just start the thing up, right? He's not doing a heck of a lot there. But now if we come and we look at the Saga, okay? Now we see a couple new things, right? I had to reference Sagas up in my class, and you see these marker interfaces. First, I have to create a Saga data class, right? So I mark this guy and I say, I contain Saga data. This is the information that I choose to store in between invocations. And you can see I have marked one of these properties as a loan request ID as my unique variable, right? So when Fluent nhibernate actually goes and builds those tables, it'll be smart enough to put an index on that, right? And I just choose to store a couple little trivial things here, right? And so down here, then we actually get into our Saga, right? So again, in keeping with that theme, it's a bunch of libraries, but the way the API works, it says, okay, well, I have a Saga. I have a container for a bunch of handlers here, and I'm going to declare that I want the framework to start a new Saga for me if I receive remittance Saga, or I'm going to use remittance Saga data as my persistence. But if we look over here, you can see it says I am started by the loan request event, right? I handle loan validation event, right? So those are the two kind of things that this Saga is built to deal with. Okay? And so if we look down, now it's going to look a lot, very much like a regular handler. So look down here, right? So this looks exactly like what we had before. Right, here's a handler, loan request event, right? So the loan event comes in, I write some junk out to the console, and then I just say data, that's my Saga data, right? I better save that information about that loan. I might need it later to validate it. I'm not going to do it yet, but I'm going to store it. And then I do this check for completion. It's just a little helper, because really at any given time, if both things are done, then the Saga is done. And so when I check for completion, I got a little helper down here that I'll show you in a moment. But then when the loan validation comes through, right, it's right here where I say, oh, okay, I better save my loan validation info. But it's right here, right, is where I would make that API call into the loan validation system, right? So any of you could do that code, right? Make a web reference, make a SQL connection, do whatever you got to do to call into that system. And that's, or I misspoke there. What we would do is a bus.send to an endpoint that handles the bus validation, right? So in these Sagas, it is key that you don't do a lot of work. You're just orchestrating, right? So you should interact with the bus, send messages, handle messages, but you do not want to write directly to a database or call an API from in here, okay? This is where you would go back now to the request response pattern and say, if I really wanted to validate this loan, I would do a bus.send of a command called loan validation request, and I'd fire that down into my loan validator, and that message might come off the bus and I call into a database or call that API, right? So again, I got these two handlers, and then down here at the bottom, I'm really just saying is if both things have happened, then mark as complete, right? And that'll go erase that record from the database and the Saga's lifetime ends. Does that make sense, how I'm using these Sagas to kind of coordinate this event cascade? All right. Yeah, you have to be smart about that, right? Because am I guaranteed that I'd actually get the loan before the validation? I'm not. So if I was smarter, I would actually make it be started by either. Because it could be that that loan event publisher is on a machine that gets snipped off the network for a moment. But the event got through to loan validation and customer validation correctly, right? So I'm not guaranteed at which order or timing. So that's a very good observation, right? I would want to make sure I could be started by either. And that's really why at the end I check for both, because I don't know which would have happened first, right? So if I would have got the customer validated event before I even knew about the loan, I'd just store that customer info hoping and praying that that loan one comes in, right? Because he should. If it was MSMQ, he's probably stuck in an outbound queue as they're repairing the network, or maybe they're patching tonight or something, right? That's one of the nice things about these systems, can be kind of self-healing that way, in that, eventually that message will get there. So you have to monitor it, make sure you catch them, but does that make sense? And so really, just in the interest of time, I could go look at the other sagas and handlers, but this is how you would build out that other solution that, in the 3 examples I gave. The messaging one, arguably you could do something like this. And so if we play it, we're going to get a bunch of console windows, right? Because that's how this demo works. In real life, you might have a console app and a bunch of Windows services running that really represent those back-end sagas, right? So it's really tough to squeeze these on a screen, not to mention at 640 by 480. But let's try, because it's kind of neat to see it actually flow. All right. So you can see this is that loan receiver, right? He's the publisher. Do you see the subscriptions came in for that guy? So if we stack him over here and we say, here's my little file processor. Now let's just watch, customer management I think goes first. This guy is supposed to go second. This guy's supposed to go third, right? Where'd you go? Sorry guys, this is one of the lost art of managing console windows. All right. But I tell you, usually we use the host for this because Windows services are harder to debug, but we do have some tools that make that much easier. All right, so let's just start this guy up. So in the file processor, I just have to hit enter, right? Okay, all right, so follow me here, right? So file processor parses a row out of the file. Right? And then you see this guy comes down here and says published loan request ID, right? And he just dumps a GUID out. Customer validated it. So this guy is not a Saga. He just checks if he's valid and declares it so. Okay, I like that customer. So now loan validator says loan request received for DBC, right? So that started his Saga. Customer validation received for DBC. Let's validate the loan, marking as complete, right? So he threw that event out. And then loan remittance said, okay, ready to remit the loan, remitting loan, blah, 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 and marking Saga complete, right? But you can see then, if I sit out here and I camp on this guy, it doesn't matter, right? What if I shut one of those off to your point? What happens? Nothing much. Right? If I start it back up, it'll start grinding away again. Right? Does that make sense? Right? So they're a little chatty, right? They're going back, pulling state in and out of these databases. But you can. The other thing to remember is if we talked about changing transports and not having to change code. If I move this endpoint to your machine and we're on the same network, I also don't change any code, right? I just change the address of the queues I'm using. Right? Or if we're using one of the brokered central repositories, I can move these endpoints around the network how I need to, or I can add more than one. right? If I'm scaling poorly out here on the lone validator, I can change the number of threads in configuration, right? So I can scale up by adding threads, and I can scale out by adding nodes, right? Correct. Yep. And so, let's imagine that this Saga is sending again, these Sagas are meant to be really just coordinators, not doers. So I skipped a whole other layer where you'd have another endpoint really for that lone validator, and he would be almost like that request response guy. He'd take in this lone validation request, he'd call some horrible API maybe, and then he'd send a reply back to the Saga saying, okay, yeah, I'm done. That could take 2 seconds, it could take 2 days. The Saga does not care, right? You can use timeouts in Sagas. There's a capability you can say, set a timeout for 2 days. Because if I wake up in 2 days and I haven't got that guy back, I'm going to be displeased, right? And I'm going to do something different, right? So they're pretty powerful, but I like to demonstrate their capacity as a event cascade thing, because that's the busway. You could sure write a Saga that did what that second demo did, where he called each guy in turn and collated the response and made one big Saga broker right in the middle. But why would you do that, right? It's so much funner to use events to do it, right? Okay, any questions? I know we're getting overtime here, and we're almost at 7:30, so I was just going to go see if I could get back to my demo here. All right, get back to my slide deck. Okay, so after the Saga demo, one of the things I really just point out is that if you're in such a system where, all right, so what could go wrong there? Imagine I do all that work to coordinate the events. Oh, come on, you dirty thing. And I just got one huge database behind all these little separate guys, right? Well, then they're just going to block each other anyway, right? So my point is you got to do some work, right? Messaging can fix some things, but if you're really kind of having an internal Rube Goldberg competition, to try to solve these things, it can be a good, useful tool to start breaking your solutions apart, right? But if you leave them all intact and you have one big monstrosity of a database, messaging can give you some durability in these kind of things, but you're still going to have that underlying contention until you start separating the data out as well, right? Okay, so we talk a little bit about service areas, because the point I was making in the demo is each of those areas were really sovereign service areas meant to contain their own data and their own logic, right? So if that customer service has no back-end tethering to the lone validator or the lone remitter, right? They're autonomous service areas. Okay? All right, guys. That is the end of my presentation. I have